We'll take a look at two proportion intervals very quickly. Quick reminder, basic formula for all confidence intervals. Remember, it was your statistic plus or minus your critical value, and then you multiply that by your standard error. Remember, the statistic for us, we either deal with p hats or x bars. The critical value, it's either a z star or a t star, and then the standard error, there's all the different forms of the standard deviation that you guys have to kind of, you don't have to memorize, but you have to be able to recognize them off of your formula sheet. So the standard error for a two proportion z interval. This one's kind of hefty looking. If you remember, we're now going to combine two different distributions. So you remember, when you combine two distributions, you actually have to combine the two variances. However, because of everything that's happening, you have n1 times p hat 1, oh, excuse me, end up with p hat 1, q hat 1 over n1, and you add p hat 2, q hat 2 over the sample of size, or of sample 2, and you take the square root of that. So you're adding the two standard deviations together. Really, we're adding the two variances, and then we come back and take the square root to get the standard deviation. So the big formula for a two proportion z interval, what we saw yesterday, we were finding, is there a significant difference? So in other words, we'd end up doing p hat 1 minus p hat 2 plus or minus, since it's a proportion interval, we're going to use z star, and then we come back with the p hat 1 q hat 1 over n1, and then your second sample might have a different sample size, and that's okay, and you just kind of plug and chug along. Again, all p hats, because it's a confidence interval, right? All p hats, because this is a confidence interval, and when you do confidence intervals, remember, we don't know the true p. We don't know the true proportion. That's why we're using all these p hats. The conditions are very, very similar to one proportion z interval. First, though, you have to realize, since we have two different sets of data, we need to make sure both are from an SRS. All right. Here, you need population 1 to be greater than 10 times n1, and we need population 2 to be greater than 10 times n2. This is kind of the one that's a little bit different altogether. So n1 times p hat 1, q hat 1. These, and then we have n2 times p hat 2 and n2 times q hat 2. All of these have to be greater than 5. So what this allows us to say is we can use a smaller sample. What you should remember from yesterday with the M&Ms, the one violation that we mentioned, and it was happening, was the NP hat wasn't greater than 10. Well, for most of us, the NP hats would have been greater than 5. We had at least 5 of each color, most of us. Real quick, why do we add those two standard deviations? Well, this is kind of going back to the very, very beginning. Remember, you always add variance, right? We're looking for a difference. But if you remember back to about unit 2, when we started combining these random variables, or we're combining two distributions, you always added the variances. So that's essentially what's happening up here. And why do we use z star instead of t star here? Well, proportion intervals always, always use z star. T star is only used for means when you don't know this population standard deviation. So, quick and quick look here. Many investigators study this effect of the wording of questions on surveys. So we have these two questions. Would you favor or oppose a law that require a person to obtain a police permit before purchasing a gun, or would you favor or oppose a law that would require a person to obtain a police permit before purchasing his gun, or do you think such a law would interfere too much with the right of citizens to own guns? So 458 out of 615 people that are asked question 1 favor the law. So a spokesman for the NRA stated that 85% of people were in favor of the law. Based on these results, does this appear true? Well, what kind of interval could we run here? And if you look carefully, there's only one proportion that we're really given, this 458 out of 615. So this would be a one prop Z interval. So chance to remind you and review this really quickly. So is it from a random? It doesn't say, so we're going to have to assume. We need more than 6,150 people. That's fair. And then a quick look, p hat, 458 over 615 equals 0.74. So 0.74 times 615. This is a large sample, so 0.26 times 615. These are both greater than or equal to 10. So everything's good there. So let's plug into our formula. The formula for us here, we need our statistic, our p hat, right? That's 0.74 plus or minus. Let's go with 95%. That seems to be one that you guys are all pretty comfortable with. So plus or minus 1.96 times the standard deviation of 0.74 times 0.26 over 615. And so what I'll do at this point, I'm done with that. I'm going to use the calculator. So the x, when you're looking at that one prop Z interval, we have 458. The n is 615. And then my confidence level is 0.95. I'm going to calculate that. Get an interval 0.71 to 0.78. So I'm 95% confident. True proportion of people in favor. From question 1 is between 0.71 and 0.78. Let's comment on the claim. 85% appears incorrect, and tell why, and that's because it's not in the interval. So because it's not within the interval. So there's a quick review. Now, we look at the next one. Those 458 out of 615 people favored question 1. 403 out of 585 that were asked question 2 are in favor of the law. Determine if there's evidence that the phrasing may have influence. Now we've got two proportions, and we're going to compare them. Does that proportion differ significantly from that proportion? So this would be a two proportion Z interval. Right? So I got two. I've got a p hat 1, which is the 458 over 615. That was my 0.74. And my second p hat, that 403 out of 585, 0.69. So if I go ahead and start filling the formula, 0.74 minus 0.69. We'll stick with 95%. That's what we've been doing a lot in here, so I'll stick with that. Plus or minus 1.96. This formula is going to be kind of a doozy. So we got 0.74 times 0.26 over sample size 1 was 615 plus 0.69 times 0.31, and that's going to be over sample size 2, which is 585. I'll fill in the conditions real quick. So they're both from an SRS. We're going to have to assume that. We need more than 615 times 10 people. Oh, and that's actually going to carry for both of these, since 585 is less than 615. So we could put this in here just to prove we know what we're talking about. And then we also need, so we got 615, so there's N1 times 0.74 times 0.26. Those are both greater than 5. That's a fair statement. And we also need N2, 585 times p hat 2, 0.69, 0.31. These are both greater than 5. And so finally, go into the calculator. We're going to run a two-prop Z interval. So x1 is 458, n1 is 615. x2 is 403, n2 is 585. Confidence level 95, so the interval 0.005, 0.107. So here we go. So we're 95% confident the true difference, let me kind of separate my conditions so they don't all run together, in proportion that favored with question 1 versus question 2 is between 0.005 and 0.107, right? So we're confident in the true difference, all right? Because 0 is not an interval, and we started with Q1 and it's all positive, it appears question 1 has a higher proportion. And that's simply because question 1, we put question 1 as P1. So when we do 0.74 minus 0.69, it looks like everything's positive in that interval.